Hello guys, so I would like us to look at loci problems. Now, a locus is basically, a locus of a point is basically a set of points that satisfy given conditions. Now, if you recall from conversion of polar complex numbers in polar form, we have R is called modulus of z or mod z and is given by evaluating x squared plus y squared square root. And theta is called the argument of z or arg z and is given by theta is equal to tan inverse of y of z. So let's take up a few questions on getting the locus, a set of points basically that are defining some particular conditions. So for example, you're being told if z is equal to x plus jy, find the locus defined by, so find locus defined by modulus of z is equal to 5. Now we know the value of z. Z is x plus jy. So x plus jy modulus, this is how we evaluate modulus. So x plus jy modulus is equal to 5. This basically translates to x squared plus y squared square root is equal to 5. So squaring both sides, we have x squared plus y squared is equal to 5. And clearly, this is equation of a circle. General form of an equation of a circle is given by x minus a squared plus y minus b squared is equal to r squared, where the center of the circle is AB and r is the radius. So in our case here, this is equation of a circle of center. The center is 0, 0, and the radius, sorry, this was supposed to be squared on this side. So this is supposed to be, if we square this side and square this side as well, so we'll get 25 here. So the radius here, this r will be equal to 5. Okay, let's take up another example. So let's take up another example of loci. So given that if z is equal to x plus jy, so this is example number 2, z is equal to x plus jy, then find the locus defined by, so find the locus defined by arg z is equal to pi over 4. Okay, fine. So from whatever we already wrote in the definition, arg z is basically theta, which is given by tan inverse of y over x. So our arg z here is the same as tan inverse of y over x, which is equal to pi over 4. Taking tan to the other side, we have y over x is equal to tan pi over 4. So y over x is equal to tan pi over 4, that is 180 divided by 445. So that is equal to 1. So our locus is given by y is equal to x. And this clearly is equation of a straight line. We know that the general format of equation of a straight line is y is equal to mx plus c, where this is the y-intercept. So here our y-intercept is 0 because it's not present. Okay, let's take up another example. So example number 3, given that given that z is equal to x plus jy, Okay, so find the equation of the locus. Find the equation of the locus. Z plus 1 over Z minus 1 modulus is equal to 2. Okay, since we already know the value of Z, so what we are going to do basically is replace the values here and try simplify this as much as possible so that we can be able to get the equation. So where the Z, I'm going to put X plus JY, then we have plus 1 over where the Z, I'll put X plus JY, then minus 1. So we need to get the modulus of this, and then this is equal to 2. So I'm going to put the real parts together and then evaluate the modulus on top separately, and then the modulus at the bottom separately as well. So I'll have X plus 1 plus JY. This is the real part. All this divided by X minus 1 plus JY. So evaluate the modulus of this and the modulus of this, and this is supposed to be equal to 2. So evaluating the modulus, that is taking the real part, X plus 1 squared plus Y squared, all this divided by, so getting the square root of that, and then all this divided by X minus 1 squared plus Y squared, getting the square root of this, and this is equal to 2. Okay, fine. So the best way to get rid of this square root is to square both sides. So squaring both sides, we will have X plus 1 squared plus Y squared over X minus 1 squared plus Y squared is equal to 4. Okay, so simplifying this, I'll cross multiply this on the other side and then open the bracket. So I have, opening this bracket, I have X squared plus 2x plus 1 plus y squared is equal to 4 into, opening this bracket, I will have x squared minus 2x plus 1 plus y squared. Okay, fine. So this is x squared plus 2x plus 1 plus y squared is equal to 4x squared minus 8x plus 4 plus 4y squared. Okay, let's try and put like terms together and see what it simplifies to. So I will bring the x squared on this other side. If I subtract, that will give me 3x squared. And then evaluating the values of x, this is minus 8x, bring this to the other side, so I'll have minus 10x. And then evaluating the values of the constant. So I have 4 here, then I have 1 here. So bringing 1 to this other side, I'll have 4 minus 1, so that will be plus 3. And then finally y, I have 4y squared, and then bringing the y to the other side, I'll have plus 3y squared is equal to 0. So I can be able to arrange this. This I can be able to, okay, divide all through by 3. I'll have this as x squared minus 10 over 3x. And then let's have plus y squared, okay, plus y squared, and then we have here is equal to minus 3. Okay, so this equation gives the locus. This particular equation here gives the locus. This is the equation defining the locus. Defines the locus. Okay, fine. Let's take up another example. Okay, so let's say we are given an example number 4. Z is equal to x plus jy, and then we are being told to get the locus defined by z plus 2 over z is equal to pi over 4. So how do we go about evaluating this? Now we already know what arg means. Basically, it means tan inverse of y over x. We already know the value of our x and y here. So we're going to solve, simplify, and get our x and y values in this particular instance. So I'm going to replace the values of x with z with x plus jy plus 2. Actually, to make it easier, let's just take the real parts. So this will give us arg z plus 2. So z is x plus 2 plus jy. I've taken this and added to this, but since x and 2 are real parts, I've put them together. All this divided by x plus jy. And this is supposed to give us pi over 4. Okay, so in order for us to simplify this, we're going to multiply up and down by the conjugate of the denominator. So I'll have x plus 2 plus jy, all this divided by x plus jy, x minus jy, x minus jy. Okay, so remember we're still evaluating this. So what is this going to give us? So opening the bracket here, so this is going to give x squared plus 2x. Then opening this and this, we'll have minus jy, x plus 2. And then this and this will give us plus jyx. And then finally, this and this will give us minus j squared y squared. But since j squared is minus 1, so we will have plus y squared. And then all this is divided by, so if we evaluate this, this is a difference of 2 squares. It will give us x squared. J and j gives us a minus, so this will be plus y squared. Okay, fine. So putting like terms together and trying to simplify, and so that we can be able to separate the real parts from the imaginary parts, I'm going to put all the real parts together on top. So I have x squared plus 2x, all the values without j, plus y squared. All this divided by x squared plus y squared, and then all the values with j. So let me have plus j out here. Then I first of all start with this one. So that is yx. And then since I didn't take out the minus, so the minus remains. So opening this up, we'll have minus yx minus 2y. And then all this is divided by x squared plus y squared. This and this cancels out. So the arg of this is what is equal to pi over 4. Now we all know that arg of y over x is equal to, now when we're defining arg z, basically, let me write it this way. So arg z is equal to tan inverse of y over x. Okay, so our arg right here will be equal to us having the value of y over x. And what is our y? Our y is this imaginary part. So I will have tan inverse of, what is my y? My y is negative 2y over x squared plus y squared. And this is divided by x, which is the same as multiplied by the reciprocal of x. So let's just multiply with, so what is the value of x? X is this value here. So we take the reciprocal, which is x squared plus y squared. All this divided by x squared plus 2x plus y squared. So this and this cancels out. So this is supposed to be equal to pi over 4 here. So what do we remain with? So we have tan inverse of minus 2 over x squared plus 2x plus y squared is equal to pi over 4. Take tan to the other side. So we have minus 2y over x squared plus 2x plus y squared is equal to tan pi over 4. And pi over 4 is 45 degrees. So tan 45 degrees, which is equal to 1. So cross multiplying, this is going to give us x squared plus 2x plus y squared, and then is equal to minus 2y. So bringing this to the other side, we have x squared plus 2x plus y squared plus 2y is equal to, so is there a constant here? We don't have a constant that is left here at all. Okay, so is equal to 0. Now this is the locus of the point. This is the equation of the locus. Now this, we can be able to complete the square and actually get it, because as I can see, it translates to equation of a circle. So this, we can be able to write it as, so let's see, this is x squared plus 2x plus dash plus y squared plus 2y plus dash is equal to 0 plus dash. So completing the square, 2 over 2. So this is going to give us 1 squared, and then 2 over 2 here. This is going to give us 1 squared. So what we added on this side is what we add here, 1 plus 1. So 1 squared, 1 squared plus 1 squared again. So what does this give? This will give x plus 1 squared. And then this side, this will give y plus 1 squared. And this is equal to what? This is equal to 2. So clearly this translates to equation of a circle of center -1, -1. So this, let me write it here, translates to equation of a circle, and the center is -1, -1, and the radius is √2. So that's it on getting the locus of a point, guys.